we'll be reviewing limits. We'll be reviewing them very intuitively by reviewing them graphically. Now first, we're going to graph a function. Set up our Cartesian plane with x and f of x. We're going to have a discontinuity at x equals 0 right along here. We'll have an open dot at f of x is equal to 1 and a closed dot at f of x is equal to minus 2. We're going to have a linear line coming straight down, coming right into that dot. And down here, we're going to be having a curve. It's going to grow up that way. First thing that we're asked is the limit of f of x as x approaches 0 from the left. This minus sign means that we're approaching it from the negative side or approaching it from the left. So we find x equals 0 and approach it from the left, which brings us right into this open dot right here. Even though it's an open dot, it's still right at f of x is equal to 1. So the limit of f of x as it approaches 0 from the left is positive 1. Next, the limit of f of x as x approaches 0 from the positive side or from the right. So we find f of x equals 0, or just x equals 0, and approach it from the right, the positive side. And it just keeps on going down. It'll keep on going down this way. Now, although it'll never get to x equals 0, it'll get really close. But it'll keep on going down to negative infinity. And next, we're asked the limit of f of x as x approaches 0 from both sides. If you review the chapter, you'll find out that for a limit to exist from both sides, the limit from each side must be the same. So the limit from the left is positive 1. The limit from the right is negative infinity. Those two are not the same, so the limit does not exist. Next, we're asked just what f of 0 is equal to. This is pretty simple. We find x equals 0 and find where the function exists. There's an open dot here, which means the function gets really, really close, but never gets to x equals 0. Down here, once again, it will get really, really close, but won't equal 0. Now this black dot means that only at this point does x equal 0, and that's at minus 2. Next, we're asked the limit of f of x as x approaches negative infinity. So we take a look at the left side of the equation. We work our way as x approaches negative infinity. F of x just keeps growing and growing linearly, but it keeps growing and growing, and it'll grow to positive infinity when we reach negative infinity. And lastly, the limit of f of x as x approaches positive infinity. So we take a look at the right side of the equation, look our way up this way. It keeps on growing and growing as we keep going and growing, and it'll keep on going that way. And as we get to positive infinity, it will go to positive infinity. For our next example, we'll be doing a similar problem. First, we'll set up our axes, label our axes as x and f of x are a function of x, similar to last time. This time, our discontinuity is going to be at x equals 3. We'll have a closed dot right at f of x is equal to 1, or 3, 1. We'll have a line that works our way up this way, and then another line that starts over here, works our way up, and works our way back down. Now we take a look at this, and our first thing that we're asked is to find the limit of f of x as x approaches 3 from the left. So we take x equals 3 right here and approach it from the left, which is this equation. So we come down, it keeps on going down. By the time it would get to negative infinity, or by the time it'll get to 3, it would have gone down so far to get to negative infinity. Now the limit of f of x as x approaches 3 from the positive side. So we look at x equals 3 approaching from the positive side. Similarly, by the time it gets to 3, it will have gone down so far that it will be at negative infinity. And the limit of f of x as x approaches 3 is, we come all the way down. It comes down from the right to negative infinity, comes down from the left to negative infinity. They're the same, so the limit is at negative infinity. Next, we're asked to justify an f of 3. Similar to the last problem, we find x equals 3, and wherever the dark dot is, right here, is that f of x is equal to 1. Next, the limit of f of x as x approaches negative infinity. Take a look at the left side of the equation, follow it to negative infinity, kind of makes a little hump here, works our way back down, and it's going to keep on going like this, following right there, but it won't get any closer to positive, or f of x is equal to positive 1. It will just get really, really close. Once again, that's positive 1 that it will approach. And our last is the limit of f of x as x approaches positive infinity. So we look at the right side of the equation, work our way up it, work our way up it. It's going to keep on going, just like the last problem, to positive infinity by the time we get to positive infinity. Thank you. I hope this lesson helped you out, and I'll see you at the next one.